Welcome to Aerospace Structures. In this particular course, we're going to learn how to design the structure of a typical airplane. There are different type of airplanes. We have military airplanes, we have commercial airplanes. Then we also have space vehicle, rockets that go to space. Then we got all different type of airplanes that actually fly in the air, and others are meant to leave our atmosphere. But regardless of what we design and how we design it, our main focus and our goal is to design a structure that will withstand the loads uh, through to which it is going to be subject to, and while making sure the weight is at the minimum as possible. That's what makes airplanes very, very challenging to design, because airplanes, when they are designed, typically have a factor of safety close to 1, or marginal safety, as we talk in terms of in aerospace structures, to 0. Um, Designing planes, it can be a little bit tricky, and it's not an easy task at all. And then there had different type of philosophies that you have, different design philosophies that are also involved into designing these planes. But we talk about this more as we go on, and we talk in chapter 1. Um, in a nutshell, we what we will be talking is mainly, is going to all our discussion will be from the textbook, analysis of metallic aerospace structures. Is This first edition is written by my brother and myself, Vinay, and my name is VJ. This is going to be the main reference that we use for our analysis. Um, so when we design airplanes, think about this. They have many, many different factors and criterias that are used when we design a plane. One of them is what we call, just give me a second to change the color. The first one is what we call aerodynamics. In aerodynamics, this is what's responsible mainly of the shape of the airplane, because they decide that they're designed to make sure that we have the maximum lift, you have maximum lift, and you have minimum drag. In a nutshell, right, in a very, very crude sense, this is what aerodynamicists do. And we shape the plane, they're responsible for the shape of the plane. Then the propulsion guys, they are just mainly responsible to determine the thrust of the plane. The thrust of the plane, this is L, this is D. The thrust of the plane is T, and has to do with with the engines of your plane. They're going to generate the speed of your vehicle. And then your controls, this is basically to help the stability of your airplane. And stability airplane, and this is used by using control surfaces around your airplane that will help your plane fly. But then it's us here that we want to make sure that the structure is completely safe. When we are designing something, we structural engineers want to make these things as heavy as possible, because our tendency is to make it safe. However, then you have aerodynamicists have a problem, because then to design something, to design a shape for a heavy aircraft has to be very, very large, and that would create a challenge for the thrust, because then what propulsion system is going to generate the velocity that I'm looking for? So this is there are many, many other aspects of it, right? But in a synthesis, this is what we do, and we just go in circles here. We just go in circles and we analyze what the plane actually does. And when we analyze airplanes as well, another thing that we consider is we have to consider many things. It's a consequence of regulations. These regulations that we talk about, they are like, for instance, here in the United States, we have FAA, Federal Aviation airworthiness, and then you have the Europe, and each one part of the world has its own regulatory agency, for which tells you what are the regulations for that particular aircraft. You have to make sure safety is met, the environment is safe, that you're meeting the purpose and mission of the airplane, and then cost and schedule, obviously. And then in a broader sense, all these have to be met for airplane to be designed. Now, when we talk here specifically, the purpose, mission, objective of airplane, that is going to come depending on if you're a military aircraft and is it supersonic, hypersonic, is it commercial aircraft, subsonic, supersonic? What are we really talking about? Then that's where I like what Albert Einstein says. He says that imagination is way more important than knowledge, because knowledge is finite, but imagination is infinite. Although when we design airplanes, we like to use the experience that we already have. We don't like to reinvent the wheel when we can avoid it. However, there are many, many times in which we have to come with solutions that are completely full of creativity. Okay? And that design process that we actually do to design a plane is involved in what we call a system engineering approach. In this approach, basically consists, these are specific milestones, and each one of these milestones, your design is frozen. By frozen, we mean that you don't go back and we don't change the design anymore. Okay? And so we might start with a preliminary idea and move our way into this. And this system engineering design actually ends up with what we call a final certification of the airplane. Okay, and the certification airplane, you can look at, this is the system engineering that we talked about in the previous slide. And in a nutshell, this is what it actually does, right? You can keep moving from the concept of operation to the detail requirement, detail design and testing, and making sure that it is the component level is safe, and then subsystem verification and operation and maintenance. And then when everything is ready and is certified, that's when we deliver the airplane. Okay, so how do we actually, as aerospace structures, how do the structural engineers fit into the big picture? The structural engineers fit in this diagram here. If you would, think about a nice triangle that you have here, okay? And this triangle, where one spot is what we call cost, the other spot is what we call schedule, the other spot is what we call weight. And the whole idea and the purpose of the airplane is somehow to stay in the middle, but it's going to all depend, because what if schedule is way more critical, then your design is actually shifted more towards your schedule. If weight is more critical, then it will be shifted towards the weight. And if the cost is more critical, then it's shifted towards the cost, right? In a nutshell, this is what your plane is actually doing. We start with the initial design, and we start with initial sizing. Okay, when we talk about sizing of an airplane, you can think maybe this is the spar that we are designing, and this has thickness 1, thickness 2, thickness 3. We got the length 1. This can be length 2, and the height. So we got all the dimensions. That's what we do in structures. We give what the dimensions look like. So with that said, we start with initial design, we do the stress analysis and make sure the margin of safety is close to 0. Margin of safety is nothing else. I'm staying ahead of myself a little bit. A margin of safety is nothing else than the factor of safety minus 1. Okay? And the ways the factor of safety is nothing else than what is available, right? The load, how much available stress can your structure handle versus how much is applied. And then what you do is you subtract that to 1, and it gives you margin of safety. But we will talk this a little bit more as we move forward. And then if this is not, is bigger or is less than 0 is failure, right? Then you have to go back here. We want to bring this very close to 0 as possible. This is what makes it way more different from your machine design car, because then your cars and trucks and many other structures, bridges, you're not so worried about bringing this margin of safety to 0, but in aerospace structures we are. So the design of an airplane is very critical because it's going to highly involve a very meticulous and careful design to ensure that your plane is actually safe. Okay, and from that you get your final design and final analysis. Final analysis goes to your design, and maybe the designer comes and say, I need more modifications. Then you iterate. Otherwise, you have met your design and this is final. Okay, so this is kind of in a nutshell what how the airplanes actually work. Okay,